For more than a century, no material has had such a profound impact on the development of cities as concrete. It is found in the bridges that span massive rivers, the dams that supply water to millions of people, the skyscrapers that dominate urban skylines, and the highways that connect entire countries. For many engineers, concrete seemed irreplaceable. After all, it is strong, relatively inexpensive, and can be produced virtually anywhere in the world. However, there is a problem that has accompanied this material for decades. The more the world grows, the more concrete it needs to produce. And the more concrete is produced, the greater the challenges related to its environmental impact, durability, and the maintenance costs of the structures built with it. For years, researchers have tried to find a viable alternative. Some invested in new materials, while others sought ways to reduce the amount of cement used. Yet very few solutions truly managed to capture the industry's attention. Then, a new technology developed in China began making experts question what once seemed impossible. Could we be witnessing the beginning of the end of concrete as we know it today? Concrete is so common that most people rarely think about it, but all it takes is a look at any major city to realize how essential it is. Buildings, tunnels, overpasses, airports, and transportation systems all depend on it. The problem is that there is a hidden cost behind this dependence. The production of cement, one of the fundamental components of concrete, requires extremely high temperatures and generates enormous amounts of carbon dioxide. And when we are talking about an industry that produces billions of tons every year, even a small improvement can have an enormous impact. For decades, scientists have searched for ways to make concrete more efficient. Some attempts achieved partial success, while others failed completely. But the greatest challenge has always remained the same. How do you improve a material that has already been refined and optimized over the course of more than 100 years? That seemed like a question with no answer. However, instead of searching for a revolutionary new ingredient, Chinese researchers decided to investigate a very different possibility. The idea was surprisingly simple. What if the problem wasn't in the composition of concrete? What if its true potential lay in the way it is treated before it fully hardens? Normally, after being mixed, concrete is poured into molds and left to cure naturally. This process has been used for generations and is part of the routine of virtually every construction project around the world. But the researchers decided to try something different. While the concrete was still wet, they applied intense pressure to it. The goal was to eliminate as many of the empty spaces within its internal structure as possible. The results quickly attracted attention. By compressing the material before it had completely hardened, much of the trapped water and air inside was removed. This created a structure that was far more compact, denser, and stronger than that of conventional concrete. What initially seemed like a minor change in the manufacturing process began to reveal consequences far greater than many had imagined. To understand why this is important, imagine a structure filled with tiny microscopic voids. These spaces may seem insignificant, but they are precisely what allow water infiltration, cracking, and gradual deterioration over the years. By drastically reducing these internal voids, the researchers were able to create a type of concrete capable of supporting heavier loads while offering greater resistance to the effects of time. Tests demonstrated significant improvements in mechanical strength, durability, and protection against external elements. In other words, structures built using this method could last much longer while requiring far less maintenance. And there was one detail that made the discovery even more interesting. Unlike many experimental technologies, this innovation does not rely on rare materials or extremely expensive components. It uses virtually the same ingredients that are already employed throughout the construction industry. The real breakthrough lies in the manufacturing process. It was precisely this combination of simplicity and efficiency that began attracting the attention of engineers and construction companies around the world. If you enjoy learning about technologies that are shaping the future, be sure to subscribe to the channel and let me know in the comments. Do you believe concrete will continue to dominate the construction industry over the coming decades? Or do you think we are witnessing the emergence of something capable of replacing it? Because the story becomes even more impressive from this point on. While researchers were searching for ways to improve concrete, Chinese companies began pursuing an entirely different path. Instead of simply making the material more efficient, they began exploring an even bolder idea. What if it were possible to construct massive structures using far less concrete? It was in this context that a technology known as B-Core emerged. At first glance, it looks like something borrowed from the aerospace industry. Instead of relying on large, solid blocks, the system uses structural panels made of multiple metal layers, arranged in an extremely efficient configuration. The result is a structure that is remarkably lightweight compared to traditional construction methods. And precisely because it is lighter, it also offers important advantages in certain applications. This opened the door to an entirely new way of thinking about construction. The company behind this technology had already gained international attention by erecting buildings at speeds considered unbelievable by conventional standards. In some cases, entire structures were assembled in just a matter of days. But as modular construction systems continued to evolve, the results became even more impressive. Components manufactured in factories arrived at construction sites fully finished and were assembled like pieces of a giant puzzle. This reduced delays, minimized waste, and significantly accelerated project completion. In an industry where major projects often take years to finish, any substantial reduction in construction time represents a tremendous advantage. And that is exactly what began attracting international attention. But speed was not the only benefit. Lighter structures can also perform better in earthquake-prone regions. When an earthquake strikes, extremely heavy buildings must withstand enormous forces. Reducing part of that weight can improve the way a structure responds to seismic events. In addition, using less concrete lowers costs associated with material transportation, foundations, and future maintenance. Gradually, engineers began to realize that these new technologies were not simply offering minor improvements. They were creating entirely new possibilities for the construction industry. For the first time in many years, some of the rules that had long seemed permanent began to be questioned. As more results accumulated, companies, universities, and research centers from different countries started monitoring these technologies with increasing interest. Pilot projects were launched, independent studies were conducted, and major organizations in the construction sector initiated research programs to evaluate the potential of these solutions. The reason was simple. If a technology makes it possible to build faster, reduce costs, and increase the durability of structures, it creates an enormous competitive advantage. And in an industry worth trillions of dollars every year, advantages of that magnitude rarely go unnoticed. Interest was no longer confined to academia, it began turning into real-world investment. Even so, significant challenges remain. No technology transforms an entire industry overnight. Regulations must be updated. Independent testing must confirm performance under different climatic and geographical conditions. Companies must adapt their processes and train their workforce. Moreover, many countries have extremely strict standards governing infrastructure projects. This means that large-scale adoption could still take years. Nevertheless, the direction seems clear. For the first time in a long while, the construction industry is undergoing changes that go far beyond simple adjustments or incremental improvements. Concrete may well remain one of the world's most important building materials for many decades to come. After all, it helped build virtually everything we know today. But what is happening in China suggests that we are entering a new era of engineering. Whether through stronger concrete, more efficient construction methods, or systems capable of dramatically reducing the need for concrete altogether, a quiet transformation appears to be underway. And if these technologies continue advancing at their current pace, the cities of the future may look very different from the ones we know today. The question is no longer simply whether these solutions work. The real question is, how long will it take before they begin transforming the world on a global scale?